Hey everybody, so this video we're going to go through naming and drawing what are called alkenes and alkynes. Essentially now we're going to get into hydrocarbon chains that aren't all single bonded together. So if they were single bonded together, we would call them alkanes, A-N-E-S. So the four molecules up on the board here, we can see that they have a double bond or more than one double bond. So to indicate that there is a double bond in it, we call these alkenes. And naming them is actually pretty easy. If you can name branching alkanes, naming these are just as easy. So first off, let's start with this molecule right there. We're still, each point on that line is still going to indicate a carbon. So in this case, we're going to have 1, 2, 3, 4. We have 4 carbons there. So we would start by calling that bute, okay? This isn't going to be butane because we're not all single bonded together. So we have a bute to indicate there are 4 carbons there. We have one double bond, and I'm going to need to indicate where that double bond is because as we can see by the other 4 molecule or other 3 molecules up there, that double bond could be anywhere. So we're still going to follow the same numbering rules we used before. We just want to make sure that we're using the smallest numbers possible. So I can name it 1, 2, 3, 4, or I can go 1, 2, 3, 4. Now when I indicate where that double bond is, I'm going to list the first carbon that's part of that double bond. And I'm still trying to use as small of numbers as possible. So in this case, my 2 options are I can call this, if I'm numbering from right to left, my first carbon with the double bond is either going to be 3, or if I number it from left to right, the first carbon in the double bond could be 1. This is the first time we actually get to use that first carbon here. The smaller number would be 1, so I'm going to use the bottom numbering system there. So to name this, I'm going to call this bute. That double bond starts on carbon 1 here, so bute 1-ene. Bute 1-ene. That just tells me that there is a double bond and it starts on carbon number 1. All right, so let's go to the next one there. We still have 1, 2, 3, 4. Prefix for 4 is still bute. In this case, my numbering, I can go 1, 2, 3, 4, or if I number it the reverse way. And I'm still trying to get the lowest number, and I'm going to figure out what gets me the lowest number for that starting double bond. If I'm numbering left to right, that double bond starts in carbon number 2, or if I'm going the other way, if I go from right to left, it's still number 2. In this case, it doesn't matter which way I number it. No matter how I number it, that double bond starts on carbon number 2. All right, jumping to this one down here. This one's actually going to look pretty familiar to us. So let's go through. We still know we're working with 4. So bute. I know I got that double on there, so I'm going to need to put an ene in there with the number on it. Numbering 1, 2, 3, 4. So I can either be number 3. Or once again, we're starting at 1, 2, 3, 4. 1 smaller. Bute 1-ene. Essentially, these 2 are the same. Whether I put that double bond at the beginning or the end, that's the only thing on it. They're just flipped. If I take this and rotate it around, it would look just like that top molecule. All right, this last one here, 2 double bonds. Okay, so I'm going to need to indicate first the starting carbon for both of those double bonds. And I'm going to need to indicate that there are 2 sets of double bonds in here. So once again, we still have 1, 2, 3, 4 carbons, so I'm still working with bute. But in this case, numbering wise, I can go 1, 2, 3, 4, or 1, 2, 3, 4. So the carbons that my double bonds are starting on, I can go 1 and 3, or 1 and 3. Once again, this is another one where the direction isn't going to matter too much. So let's just say that we're going to start with carbon number 1, and we have the double bond starting at number 3. All right, so we indicate what carbons or double bonds are starting on. Now, to indicate that there are two sets of double bonds, I call that a diene. But 1,3-diene for that one. So, di for 2, there were 3 sets of double bonds there, which is possible. I would call that triene. All right, so let me scroll down. So that covers double bonds pretty well. Looking at these, we have some triple bonds, and we start to see things bonded to our triple bonded carbon chain. So we're going to start up here in the upper left-hand molecule here. We have, this is a triple bond now, indicated by the 3 lines here. And granted, I drew that triple bond starting at the beginning. So first thing first, figure out how many carbons we're working with. 1, 2, 3, 4, 5. So I'm still working with, so I'm just added a carbon to what we were working with before. Prefix for 5 is pent. Now to indicate I have a triple bond, I'm not working with alkanes, I'm not working with alkenes. This time, if we have a hydrocarbon with a triple bond, we call that an alkyne. And once again, we still need to indicate what number of carbon that's on. So my numbering system is either going to go 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. Just like with the double bonds, I just need to indicate which carbon starts the triple bond. My options here were 1 or 4. 1 is much lower than 4. So I would call this pent-1-ine. You might also see it as 1-pentyne. Sometimes, rarely, they might move that one. This tends to be the more acceptable way to do it. All right, and then ines just work the same way as enes. Just indicate where's your triple bond at, what carbon starts it, end it with Y and E. If you have more than one triple bond, diene, I guess is what you'd say. Let's look at this molecule here. Starting off with, we can see that there are 1, 2, 3, 4, 5, or 5, either way you want to go. So we're still working with the base 5 molecule. I would even say, numbering-wise, where we're trying to use the lowest numbers ever. We saw that triple bond starting at 1. So this part is the same. Does that one make it? I can't tell. It's not. Why is that 1 working? There. Good enough. Pent-1-ine. Having a little bit of a malfunction there. But now I still need to indicate where this part is. Essentially, this is an alkyne, a hydrocarbon chain with a triple bond, that has a carbon functional group on it. And just like last time, we know this indicates this is a methyl group. And when I numbered it before, I said that was 1, 2, 3, 4, 5. Okay, so that methyl group, this one carbon group here, it's on carbon 4. And we said that it is methyl. So that is 4-methyl pent-1-ine. The names start to get a little bit more cumbersome, but they're super descriptive. They tell us where everything needs to go in that molecule, as you see my message there. All right, and I need to hurry up now. All right, so this one here, we're still working with pent. So pent's still my base. This time, though, my triple bond has moved. It's no longer on carbon 1. This time I would say my triple bond starts on carbon 2. So pent-2-ine. I still have a methyl group attached to it here. This time though, and once again it's on number 4. So 4-methyl pent-2-ine. Alright, last molecule here. I drew this one just to kind of point out there's something wrong here. I can't just rearrange all of these things and have it exist. There's something very wrong with this molecule right here. Give me a chance to think about it for a little bit. Remember, these things have as many hydrogens on them as they need to do, as they need to have to get up to 4 bonds. We just don't indicate them. Like if I come back over here, this carbon has 3 hydrogens on it, because it only has 1 bond to another carbon. This carbon here only has 1 hydrogen bonded to it, so it already has 3 other bonds. This carbon here, so come back to the molecule in question, would have 3 hydrogens on it, so it only has 1 other bond. This carbon would have 2 hydrogens on it, so it has 2 other bonds on it. This carbon here, 2 as well. How many bonds does that carbon have? I'm looking at it right now. It's a triple bond there, so that's 3. This bond here is 4. That bond there is 5. Carbon, for all intents and purposes, cannot have 5 bonds coming out of it. So you can't have, that triple bond means our methyl group cannot be attached to carbon number 2 in any of these 3 molecules. I can have that methyl group coming off of number 3 here. I cannot have it coming off of number 3 there. But just know carbons, 4 bonds max. And yeah, that should cover it. With that, there should be some practice problems up. Good luck.